Okay. I would like to spend a few minutes on the exam, the answers. If you have questions about the score you got, please send me a message, an email message. Unfortunately, I'm going to be a little busy until next Wednesday. The reason is I have another visit to an institution coming up this weekend, but we will have regular class next week. I don't have any clash in the evening, but I'll be busy reading a lot of reports and doing interviews and stuff like that. So I may not get much time to look at your requests in detail. So if you have questions about the way I graded you, please send me a message. I will look at all those things in detail sometime next week after Tuesday. Okay. The visit ends. It's a virtual visit, but it ends only on Tuesday afternoon. So I'm sorry I won't be able to look at anything in great detail until then. Also, I will not be able to grade your projects until sometime the middle of next week, but it is due tomorrow. We are going to look at the next project tonight. But let me show you my answers to the exam questions, the two programming questions, that is. The other thing you can take a look. I hope I have made it available to you, but I don't quite remember the multiple choice. You should be able to look at it, I think. I don't quite know how D2L protects these things. So if you are not able to access it, let me know. Otherwise, you can look at your answers and see where you went wrong, if you went wrong somewhere. Let me let me show you the code I have for the first and second, or the two programming questions. Let me share my screen. Okay, let's. Right, the first question asks you to get the titles of all books that are held by a particular member. So I introduced a new command here, get held titles 13, and I pushed save and help to 14 and 15. And I have I have help updated. I don't quite remember where help is. Let me find out. Yeah, here I added one more line here. That's simple. And towards the end, I have the process method, which is updated. I have some extraneous methods here for testing, so ignore those. Like this one, test new functionality, that is just to test the new functionality. You can ignore that. But here is case get held titles. I have a call to a method called get held titles. And that is at the very end. It is here. So I get the member ID and put it into the request object. And then I call a method called get held titles in library. I pass the request object and I iterate on the result, which is an iterator to results, essentially the titles of books, and I print the book title from the result object. So result.next is the next result object, and I get the book title and I print it. So that is user interface. And library has get held titles. This is a new method, and you can see that I'm calling get book title from user interface. Sorry, get held titles from user interface here on library. So I'm going to go here from user interface. So I get a request object just like any other command, and I create a result object, and I search for the member's existence. And if such a member could be found, I create a linked list. And here is the member object gotten from the member list. And I go through the holds for this member, and I get each and every hold object and get the corresponding book object and put it into the linked list. And finally, I use the save book iterator to return the iterator to a result. Some of you actually had some of you actually got the holds list from member. That was fine. Then you created a save hold iterator, which is also fine. So this is the code I have. If the member is not found, I create an empty linked list and return its iterator. That is the code. Any questions about my code here? As I said, if you have questions about your answers, please send me a message. I will look at all of them sometime middle of next week or so. Okay. All right. The second question is asking you to refactor the event class, which is very much like the class exercise we had a couple of weeks ago. And we had an event class which had several types, like play, movie, and non-profit, etc., etc. So what I did here was get rid of all the type-related information. I have a number of fields that store the name of the event and various aspects of these events. When you create an event, you get the event name and store that. Then I have essentially the same set of getters and setters here. But what you need to note here is that I have a method for, not this one, dues to get the dues to client. And here I implemented the most common method, which is the dues for dues for the profit events like movies, concerts, and so on. Because that is the same for all those classes. So I put that in the super class, and the non-profit meeting extends event, but then I override get dues to client and return 0 here. For the other ones, I simply store the stuff into the various fields of the superclass. That is the code. Okay. Any questions about any of this code that I have here? All right. If you don't have questions, let me stop sharing that. And the first project is due tomorrow. I hope the Dropbox is accessible to you. If not, please let me know. I will look at it again. I think I made that available. Every member of every, or rather, let me put it this way, for every group, all the group members should have access to one Dropbox. So all groups have 5 members, and or at least almost all of them, and all those 5 members should have access to a single group project. I think you should discuss among yourselves to see who is going to submit the stuff so that there is no confusion for you or for me. Sometimes I have seen in past years multiple students submitting, and it is sometimes confusing as to what you wanted me to grade. So please submit only one version. I mean, you can submit multiple versions, but I think only one person should be submitting things. So you can designate that person. It will be much easier for you and me. So you will know who submitted, who is responsible, and I will know. I won't have to choose between 2 things because it takes a lot of time to test these things. So please do that. The second thing is I would like to chat with each group this evening and see how things went. And we also have the next group project. So let me see if you have any questions about the first group project, about its submission or anything that you want to discuss at this point. All right, hearing none, let me then show you the next group project. I know you will not be able to focus on this all that well, but I wanted to convey some big points regarding the second group project. I'm not going to get into nitty-gritty details. That is probably not appropriate at this stage. You will be much more ready to do it after you have to see my explanations, after you have had a chance to read the group project, and which is not going to happen until you submit this one, I think. But let me go ahead and show you the handout. And this group project, the handout is here. It's due more, I mean, in about 30 days, I think, December 7th. So that is probably after the final. I don't quite remember, one day after the final or something. And what you need to do is implement, design and implement, analyze, design and implement a system for playing videos. I mean, you are not going to actually create a player, but you will be creating a lot of the functionality for controlling the player, right? So the interface would look like this. So you will have an interface like this, a graphical user interface, which should be implemented using Java FX without any FXML. You should do everything using pure Java code without FXML, okay, from scratch. And there are a number of buttons. You can read all that: on, off, play, etc. They mean the typical, I mean, they have the same meaning as a typical player: fast forward, rewind, and so on. And there are There is a bunch of shows that you can watch. You can watch any one of these shows. So it's a limited number of shows that you can watch. You don't want to have Netflix here, right? So you should be able to watch any one of these shows. Otherwise, it shows if you don't watch any shows, after a while, this starts showing the screen saver, which is ICS 372. That is the typical interface. What I want to tell you is this is very much like the microwave example that we have been discussing. The microwave is a device and it has certain controls. We used the finite state machine approach to analyzing it and designing it. We have the state transition diagram, state transition table, which have the same power and so on. So this is like that. This is a device. You cannot be approaching this using the use case model like the library or the grocery shop. Then it would be very hard, if not impossible, to program this. So you must use the finite state machine approach. This is what you should really understand at this stage. I mean, tonight, even though you are really focused on the first group project, please understand this aspect. The real work, the real original work for this would be mostly in the analysis stage, where you look at the behavior of this device and see or come up with the state transition table or state transition diagram, one of the two. Both are the same, essentially. So that is the real tricky part. You need to identify the states, you need to identify the events, and you need to see what happens when you get an event in a certain state. That is the most difficult part. If you can get that correct, the rest is fairly easy. The design and implementation would all be very, very easy to accomplish. That process, the coming up with the state transition table or diagram, requires a lot of thinking. You need to understand the behavior of the device and see what the states are, what the events are. I feel the events would be much easier to arrive at than the states. There may be a few tricky things related to states. I will let you figure that out. Once you get the states and events correct, then go ahead and design and implement it. It should be fairly straightforward. I will show you the overall structure of the microwave, and that should be the starting point for you. The implementation for the second group project should be based on the implementation for the microwave. You should be able to adapt it very quickly. The actual implementation shouldn't take a lot of time. I mean, it shouldn't be, at least not very difficult. Let me put it that way. It is fairly straightforward. There will be a lot of code to write, but it will be fairly routine. But the difficult part would be actually figuring out the state transition table or the state transition diagram. And that you can arrive at only after you have understood the behavior of the device, which is quite intuitive, but there may be a few little things here and there that you probably need to be paying attention to. So I will let you read this document understand what this device does. To repeat, most of it is actually straightforward, but there may be a few things that are not quite consistent with all the devices that you see, because every device has its own quirks and fancies, right? So there may be slight differences here and there, but nothing substantial. But you should analyze it based on this, based on the requirements given here, not what you imagine. Okay, you might get into, you might have questions in the middle of the analysis because you may not understand the requirements by reading this document. If so, of course, you can ask me. But this analysis probably will take you a couple of weeks. Maybe you may not get your analysis done properly until after you come back from Thanksgiving. Don't worry too much. The code is fairly straightforward. You should be able to adapt the code that I have given you for microwave very easily. Okay. Any questions? Okay, then let me stop that and let me show you the code for the microwave. I'm not going to go into every detail here, but I will show you the overall structure of the code and also tell you what kind of things you will be doing for the second group project, how you should be adapting things. I will go over that a little bit. Okay, so the implementation for the second version of the microwave is on D2L. Download it. You need to download it for tonight's class exercise. The class exercise is entirely based on that implementation. So you need to download it at some point in time before you start the second class exercise. You might want to download it right now. I will show you the structure right now. All right, so the name of the project, I mean, the name of the file that I uploaded would be different from this, but the project name should still be the same. It has 5 packages. It's a modular project. When you run this stuff, to run this actually, you need to go to the start package and run the main file here. I think I have set it up. Let me see whether it will run right now. Okay, well, I think I should show you the execution. So I need to change the share. So this is the interface, and it's a very simple interface. The door is closed, the lights is off, it is not cooking. So if I press cook button, it cooks for 10 seconds. It should really be 60, but I don't want to make it go for 60 seconds because then testing will take a lot of time. Demonstration will also take a lot of time. So I just changed it to 10 for the purpose of demonstrating, right, and testing. And it ended now, cooking is over, so it goes back to door closed, light is off. I can open the door and the light is on. It says door is opened, it's not cooking. If I press cook now, it won't cook. if I close the door and cook, and I can keep pressing cook, it adds 10 seconds. It should really be adding 60, but I changed it to 10 again. And if I open the door, cooking will end, unlike a real microwave. So that is the behavior. A very simple interface, very simple behavior, but the implementation is a bit elaborate, so it can actually be adapted to more complex systems like the player that you are going to implement. You will see that the basic implementation that I have here is easily extensible to more complex systems. So let's go to that. Let's go and see the implementation here. As I said, there are 5 packages, and you saw a bunch of buttons on the interface like cook, door open, and so on. Those are all here. Those buttons are here. There is a display class, GUI display, which implements microwave display. So that is the actual JavaFX window, and all the controls are inserted into this window. So you have instances of these buttons and so on. Then there is a states package, which contains all the states that you currently have, and there is a timer package. So this is the overall organization. You should be able to take this set of packages and use it exactly. Of course, the classes will change, but the packages should probably be the same for your group project. I don't see any reason for changing the packages. Or in other words, this basic organization of classes, the basic design approach, the basic structure should all be extensible to many, many, many systems. So if you have a new button, just add it here. If you want to change the display, you need to fix that over here. If you might have perhaps 15 states in your project, like the second group project, then you put those 15 states over here. You probably won't need to touch this. I am suspecting that you will not need to touch this because this is so general. You probably won't have to do anything with it except maybe change the comments and stuff like that a little bit, nothing else. So you should be able to lift this and adapt it very easily, okay? So let's take a quick look at some of the classes, not everything. Let's look at one of the simplest packages, which is the buttons package. The buttons package has a class called GUI button. It is an abstract class. It extends the button class of JavaFX, and it responds to clicks on the button. So every button reacts to clicks on itself. So when you create a GUI button, you need to give a string, which is the label for that button. And the button says, I'm going to handle clicks on myself. You are not giving it to a frame, or rather, you're not giving it to any other object in the system. Every button is responsible for handling clicks on itself. That's it. It's an abstract class. So let's look at one subclass, cook button. What does the cook button do? It extends GUI button. And when you create a cook button, you have to say, what label you want. This could have been avoided perhaps, because the cook button should know that it should be called cook. But we give that authority to the unit that is creating the cook button. And when the cook button is clicked, control comes here, because we have in GUI button this statement, set on action this. When there is a click on a button, that button should be handling it. So cook button will get clicks on itself. And then what it does is it calls the method called onCookRequest in microwave context. So microwave context is a singleton class. It has a single instance. I used get instance instead of instance. And I'm calling the onCook method of microwave context. So where does control go? It goes to the microwave context class, which is in the states package. This is a singleton class, right? So when you press the cook button, control comes here, because when you press the cook button, control comes to this handle method, which calls the onCook request. OnCook request method. And onCook request method, all it does is simply calls the current state's onCook request method. So the context is keeping track of the current state. All these things would be very, very similar to in the group project. You will find it is very simple to adapt this. In fact, all you will need to do is change the state name here to change the current state. But of course, the method names would all be different, because it's a different kind of device. In any case, I have a method called onCookRequest here, which calls a similarly named method. It is easier for me to visualize it that way. I'm giving the same name. The context has onCookRequest, which calls onCookRequest in the state class, which is microwave state. So microwave state is an abstract class. It has methods for handling every kind of event. When cook is requested, when door is opened, when door is closed, when the timer ticks, when the timer runs out, these are the events of the microwave. There are 5 events. So they are all handled by objects of type microwave state. There are 2 methods here that I added in addition to the events, that is enter and leave. When you leave a state, you call this method to do to undo anything that you might want to undo. And when you enter a state, you call this enter method so that you can set up some stuff if you need to. Otherwise, you just have empty body for enter and leave. So you can see that I have empty methods for onCookRequest, on door open, on door close, and so on. So you don't have to define these if you don't have anything else to do. So cooking state is one of the subclasses of microwave state. And when cook is requested, control will come here from the microwave context class, and we would have a timer object set up by then, and we add 10 seconds to it. So you can see that there is a timer object, or timer reference rather, here, and that we set up when we enter the cooking state. So when we enter the cooking state, we create a timer class, timer object, and we adjust the displays. And and in on cook request, we always add 10 to the timer value. So even if it is pressed again and again, we will keep on adding 10 seconds. When door is opened, we change the state, right? When timer runs out, we show that there is 0 seconds left, and we change the state to door closed state. So you can see that the state transitions are all implemented in a local fashion. We don't have any global state transitions. Every state knows where to go when a certain event occurs. And when you are leaving the cooking state, for example, when you finish cooking, the context will call leave. And what it does is it stops the timer and sets the timer reference to null, so that the timer is destroyed. The next time you cook, you create a new timer. There is an enter method here, right? And that is how it goes. And this is not worth talking about in any great detail. This is just a JavaFX program, JavaFX class, basically, essentially. It sets up the window, nothing more, nothing very difficult about it. It's routine code, extremely simple code. And the timer package is also very, I mean, I don't say it is simple, but it is not something that you need to change much. There is a clock class, which is rather universal in the sense you can use it for almost any application. It is a thread. So there is a thread reference here. When you create a clock object, you need to convert this to a thread. So that is done by this line. So if somebody creates a clock, which is done through the get instance method, the moment the clock is created, it becomes a thread because of this. And this thread gets started. So that happens over here. So this runs independently of the graphical user interface. So the graphical user interface is running on its own. This clock is running in parallel. So the two are running in parallel. That is the property of a thread, right? The thread is, when you say thread.start, control comes to the run method, and this is in an infinite loop, sleeps for 1000 milliseconds, that is 1 second, and then fires a property change to all listeners. If there is no listener, nobody will get any message. Otherwise, any listener to the clock will get a message every second, more or less every second, because there will be a little delay because of this. So the gap may not be exactly 1000 milliseconds. It may be 1000 point plus a few microseconds, perhaps. So this is in an infinite loop. It simply notifies all customers. So this is an observable. You have read the observable thing in the reading, right? The observable pattern. And the observer is a timer. A timer simply starts with a certain value and counts down until you hit 0. So you may have a timer for 60 seconds for cooking, perhaps, or 10 seconds in the testing phase. Right? So the timer is okay. The timer is a client, so to speak, of the microwave. So it implements property change listener whenever the clock sends a message through this fire property change, the timer gets notified here, the property change method. So this implements property change listener. Okay, that is how the observer and observable are connected. This is an observer. Timer is an observer of the clock. The clock is an observable, so it implements, or it is an adapter. The adaptee is property change support. The timer, when you create a timer, you do it because somebody needs a timer. So in this particular device, it is a cooking state that needs the timer. So this would be the cooking state object, and this would be 60 or 10 in this particular implementation because I'm testing things, so, or demonstrating. So time value would typically be 10 in this particular instance. So I store all that and then become a listener of the clock. There are methods to add time because I need that functionality, right? I need to be able to add stuff, and I can stop the timer, which means I will be removing myself as a client. I have a method to return the timer value. And as I said before, when there is a clock tick, the clock calls the property change method indirectly. It actually calls the fire property change method, which calls property change method, and I check whether timer value is now equal to 0. If it is 0, then I'll be telling the client that time has run out. The timer has run out. Otherwise, I will simply tell the client that one more second has elapsed, and I will give the current time value. So as you might observe, this is eminently reusable. There is very little need to change anything over here when you need a timer. You might want, in a very sophisticated system, to have more complex operations on a timer. If that is the case, then you need to change it. This is the notifiable interface, right? So that almost any class can become a client of the timer. The timer is a client of the clock or an observer of the clock, and the cooking state is a client of the timer. That's pretty much it, a summary of the implementation. Do you have any questions on this? If so, we can go over that in more detail. Otherwise, I will wrap up the stuff right now. And once again, we will have class next week on Monday. I will have no office hours on Monday or Tuesday because I will be in meetings most of the day. I have a Monday morning class which I'm canceling, and or maybe holding it for an hour or so. I will not have any office hours on Monday or Tuesday. And all my meetings will end Tuesday afternoon sometime. But I may not be able to do much grading this week and until next Wednesday. Okay, any questions? So there is class next week, okay? All right, then let me stop recording.